My friends, the common question that rises anyone's mind after going through about disjoint sets is what for we are studying this and how are these disjoint sets help us in our real life, how they are formed in real life and so on. So in this regard, as an example, we can talk about using a search engine for searching some keyword. So if we search something, so the most common place to look for details is say Wikipedia. So we get into Wikipedia and then see what we get. So let's as an example, let's see, we search for say disjoint set data structure, and we got this page which we call a home page. This has got many details in this, so it has text, it has got some animations, it may have pictures, it may have videos, clippings and all, many things may be there in a web page. In this case, let's as a simple example, let us see the text part of it. Okay, so we have some explanation about disjoint set data structure which we searched in Wikipedia, and we found some text, and you can see that most of the text is in black, except a few words here and there are found in blue. So you are very well aware that these blue are providing links to other web pages of Wikipedia, so that if you are interested in finding more details about this whole text, whatever is appearing on the screen now, is overall talking about what we searched, that's a disjoint set data structure, and it's giving the overview of that, and we find that without understanding others in detail as a background, we may not be able to understand this whole thing, because this is not a beginning of any particular matter. It may be part of a journey. So past journey has to be looked upon to understand the actuals of what we are looking at. So this can be done in the form of a big list, or it can be very intelligently arranged such that if you are already aware of that, you can just go through the whole text. If you are having any confusion, any doubt, just click on that blue text, which will get you to the concerned web page where more details about that is available. So when you get into any such thing, like if I look for what this minimum spanning tree is, and when I click on this, then I may get another page opened which is from Wikipedia again, and this gives me in detail about what minimum spanning tree is and all that. And then, as expected, it contains again the text and other things, and most of them is black, but few again are in blue, which tells that if you are not clear about what this is, then you can click on this, which leads us to another web page and so on. So this is how the whole thing is intelligently arranged, so that whenever you are working on any particular issue, then this whole thing comes up. Now let's get back to our screen where we can see what we were doing. So we started with some search, and that showed a page. In that page there are many extensions or links are available. So when you press any other link, one more page gets opened, and that also has many links. And from this page, if you press this particular thing, then you will open up another web page which may contain many more extensions for more details. So that's how the whole thing is arranged. So this is an example of searching. So this way we keep searching in the browser, and the effect of this is we can build such a disjoint set. It says that this particular web page contains links to these other web pages, and this particular web page contains links to these web pages, and this particular web page will contain links to these web pages, and so on. Now the issue is, what exactly we are trying to say is all these say 2, 3, 4, 5, 6, all these are somehow related with the topic we searched in 1. So they are not independent things, they are somehow related. Whereas this 7, 8, 9 are in some way related to the topic of 3, and similarly 10, 11, 12 is somehow related to topic of 8, and so on. That's what we were trying to say. So in all, we can see that when you are talking about this whole structure, we can say that the topics 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 are somehow related with one another. So we can say all these belong to one set. So they mean some particular issue, so they are related with some particular issue in some way. So we are interested in working this way, because once we get an idea about your searching pattern, that you look for one, then we found so many, and in that 3 you found more interesting, so you pressed on 3, then 7, 8, 9 came out, and then in that 8 you found interesting, so 10, 11, 12 emerged. If you had pressed 5, then some other things would have come. If you had pressed 6, some other things would have come. But as of now, we have done this particular search action. So we search for one topic 1, then in that we wanted more details of topic 3, then in that we wanted more details of topic 8, and that way we continued searching. And this way we can think that this particular structure, whatever is drawn, is talking about my searching behavior. So if Wikipedia is following this type of my behavior, then it can do more efficient way of searching for me. It can provide a better searching path for me, so that I can get the things at the earliest. So searching can be done easier. A similar logic is used in most of the search engines, especially the Google search engine is making use of this concept, how it is used and all that. So we just look in our coming sessions. Thank you.